Okay, so we're going to continue on with some identities that are a little more involved, but also kind of naturally result. So in this case, we've got Pythagorean identities. So the first one here is telling us that if I take the sine squared of theta and the cosine squared of theta and add them together, I get 1. And that's exactly because the circle is a radius of 1 and sine and cosine are points on the circle. And that's exactly how you create a formula for the equation of a circle centered at the origin. So there's nothing too mysterious happening here, but let's just bear this out. Okay, so there's our handy dandy unit circle. And this just means if I take, for instance, a square root of 3 over 2, square it. Now remember, that's the cosine. Plus the sine, which is 1/2. Okay, it equals the radius squared, or 1. 1 squared is 1. Okay, so this is the sine squared. And just to remind you, if I ask for the sine squared theta, I'm really just asking for the square of a result of the sine of theta. So this is like a common way to ask for the square of the result sine theta. They'll just kind of write it sine squared theta. So you can see these two might be given to you in either form, but it does the same thing. So when I square this, I get the square comes off for the 3, and then the bottom is a 4. And then when I square this, I've got 1 squared is 1 and 2 squared is 4. And sure enough, when I combine my, when I write this together, that's 3 plus 1 over 4. That equals 1. So no matter what points we pick off of this, it's going to bear that out, that the cosine squared plus the sine squared theta equals 1. Okay, so this is what we just discussed here. And you can rework this any way you want. If I wanted to subtract cosine theta, cosine squared theta, then I could use this identity and recognize that a sine squared of theta is equivalent to 1 minus a cosine squared of theta. And this also generates, if I kept the cosine squared over here, I would have to subtract the sine squared, so that'd be equal to 1 minus sine squared theta. So I can rework this however I like. Let's look at the next identity. Okay, so these are called the Pythagorean identities because they are basically, when we look at a triangle, we'll see that these endpoints on the circle relate to right triangles. But for now, we just know that the equation of a circle makes these hold up. And so if I have a tangent squared of theta plus 1, I can get a secant squared of theta. And then, of course, we could build our own tangent squared of theta must also be equal to the secant square, to the secant squared of theta minus 1. Or any reworking of this equation, we could balance it however we want. Here's the next one. Cotangent squared theta plus 1 equals cosecant squared theta. Okay, so these were the fundamental identities here that we talked about last time. And now we add in these Pythagorean identities, and it's going to fill out what we call the fundamental identities that we can refer to. Okay, so that might be something to save along with your unit circle. Okay, so we're going to find exact values of these expressions, and we're not going to use a calculator. Okay, so now we want to take a look at what happens when we put some of these fundamental identities to use here. So I'm just really not doing anything too terribly complicated here. I'm just going to take and rewrite these in a way that will help me simplify this. So if we think of the cotangent of 40, remember here we can write a cotangent as a cosine over a sine. So I'm going to change this to the cosine of 40 degrees over a sine of 40 degrees. Guys, that takes care of that. And then if I rewrite the cosecant here on top, the cosecant is 1 over the sine. I'm going to have 1 over the sine, 40 degrees. And then on the bottom here, the secant is 1 over the cosine. Okay. And so obviously I want to simplify this fraction. I'm going to end up flipping them. So this is going to turn into cosine of 40 degrees over sine of 40 degrees. And then minus cosine of 40 degrees is going to go on top over sine of 40 degrees. Okay, so since we end up with this value minus this value, these are the same. So no matter what, because of the structure of this expression, it's going to evaluate to a 0. Okay, let's look at this next one, B here. It says 1 over the cosecant squared of pi over 16. Now we know from our identities that cosecant can be thought of as 1 over sine. So I'm going to rewrite this as 1 over sine squared pi over 16 plus cosine squared pi over 16. Okay, now this just simplifies. I'll flip that up on top, so we get sine squared pi over 16 plus cosine squared pi over 16. And we really recognize that this is from the first fundamental identity for Pythagorean that says sine squared theta plus cosine squared theta equals 0. So this actually, the entire expression we started with is just a kind of hard way to write number 1.